We have a closing keynote coming from Braden Hancock, who is a co-founder and head of technology at Snorkel.ai. Braden is an undergrad from Brigham Young University in mechanical engineering, has done his research in AI at some of the most prestigious institutes in the world, MIT, Lincoln Laboratory, Stanford, and last but not the least, Johns Hopkins University. His talk is going to answer and address a very key question which everybody has with large language models, generative AI, and that is, how is it going to play out when it comes to specific vertical use cases? Braden is going to talk today about how the foundational models are going to evolve and going to be actually be fine-tuned, what you can say inferencing out at the edges for specific verticals and use cases. So Braden, without further ado, our last keynote speaker, Braden Hancock from Snorkel.ai. Thank you.
All right, thank you so much for that introduction. Thank you all for being here. Fantastic crowd, fantastic earlier sessions. It's a fun time to be in AI, isn't it? Just blistering pace. It feels like every morning you wake up, check the news, and there's a new announcement, new product, new benchmark, new data set. Just super interesting, super fun, kind of exhausting, but kind of fun. And the pace is such that, just recently talking to, it was a director of data science at one of the Fortune 500 companies, and they said basically we're having these existential questions and debates internally. Is it even worth it for us to continue trying to develop, internal bespoke AI, or do we just wait for GPT-5 to come out and solve all our problems, or Palm or Bedrock or whatever, the other models that are being produced? And I've got a pretty strong opinion on that. I'm going to share today in this presentation why, based on the evidence that I'm seeing, the conversations that we're hearing both from academia as well as industry, why I think that's very much not going to be the case, and why I think we're going to see a trend toward more what I call GPTU, not GPTX. So without further ado, we'll hop in. Essentially, the premise I'd start with is, foundation models clearly here to stay, I would say. And useful for a number of things. There are the generative use cases. That's on a lot of people's minds. Generative AI, create very realistic images, text, audio, video, et cetera. There's also their use for discriminative use cases or predictive use cases. That's where I'd say most of enterprise value is today in terms of AI usage, where you're automating something, automatic decisions, automatic predictions, extractions, et cetera. And in terms of terminology, there's a number of different terms floating around, but I really like that foundation model description the most compared to, say, LLMs, large language models, or Gen AI, because of a number of things. First, these are not just about text. They're not just about language, large language models. These are making a big difference in multimodal, as was mentioned, or other types of modalities. It's not just about generative AI because so much value is being driven from the predictive use cases. And then finally, this idea that these are a foundation is so true. Most of the time, this is not the house. This is the foundation that you're building on, that you're adding to, that you're doing a lot of that free work, kind of not starting from scratch, but then there still is a last mile that needs to happen. So I think at this point we are now caught up, getting to the outline. The three reasons why I believe that the future looks a lot more like this GPTU rather than GPTX. One being the closed AI APIs aren't particularly defensible. Two, the durable moat is data, in particular private or unique data that these enterprises have. And third, that the last mile is where the real value is generated, and how that plays an important role in actually shipping AI products. Finally, I'll just a bit of a bonus, I guess, talk about once models like these GPTUs exist, there's an interesting opportunity for these to become an appreciating asset, which I refer to as the GPTU flywheel. So let's hop into the first piece. Closed APIs aren't defensible. So much of this content is so fresh, per my earlier comment, that a lot of these things are coming from April or March of this year. This is one of those great infographics that was recently produced outlining some of the history of how we got here in terms of large language models. And if you've been in the field for a while, it's fun to walk down memory lane and see things like that bottom left corner I think of as the Sesame Street years, where Elmo embeddings were big, and then came the BERT model, and then Distilbert and Roberta and Big Bird and Ernie, and it was wild. It was fun, kind of like now. But basically, I'd say the main point to take away from this is just there are a lot of models out there coming from a lot of places. This isn't even anywhere close to half of them, but a lot of these are open source everywhere you look, and increasingly over, especially the past couple of months, we're seeing great alternatives to a lot of these closed APIs, which maybe someone hoped would be that model is all you need, stick a wrapper around it and make great margins, but in reality that's going to be very hard to defend. And part of the reason is that these models that are behind an API are surprisingly easy to clone. So again, this is a small subset of the activity that's happening, but just as one sort of case study, ChatGPT was released back, I think, November 30th of last year, so close to the end of the year. In February, Meta released an open source model called Llama. Both of these, presumably, Llama did report more of their costs. ChatGPT, people only guess, but easy to say millions of dollars went into the development of these models. In the case of Llama, they intentionally released it open source, though with a restrictive license where it could be used for research only. Wait a month or a couple months and you see these alternatives start to pop up. So Alpaca was a project out of Stanford where they said basically we're going to take the Llama backbone, the Llama base model that's been done all this kind of self-supervision to get basic good pre-trained weights, and then they basically just took the outputs of ChatGPT, questions that they sent, made a little training set out of that, fine-tuned that Llama model, and got a model which they called Alpaca as a sort of Llama derivative that was evaluated as approximately equal to ChatGPT in terms of how users preferred the responses. It cost them, they reported, about $600. Some number to get the data set that they pulled out of ChatGPT, and then a little bit of training, but not that expensive. Wait another month, or actually I think more in the order of a few weeks, and Dolly, a clone of a llama, came out, where Databricks said, hey, we used that same data set and trained a different model that had a more flexible license. Now you've got Llama, but you can use it for commercial purposes too. And again, kind of showing a decent level of quality, and cost them $30 to do. Red Pajama is another one I'll call out, again playing on this Llama theme because we AI researchers love to do this name game. But basically they said, hey, let's take the formula for how Llama was made, do it again, the same data sets, the same backbone, but we'll train it fresh and then again release it open. So all this is to say, never underestimate, I guess, the rate of progress from an incentivized open source community. And we're seeing that very much happen right now where there's not necessarily going to be a reason, especially when you consider privacy or other competitive constraints, to send data to closed source options when you could just as easily or straightforwardly use an open source model much of the time. And the timing of all this is unfortunate just because this morning a real gem of an article dropped as well, a leaked internal memo from Google reportedly, from one of their engineers basically making exactly this case. They're saying, why would we want to bet on a closed source model when you take a look outside and see that in 2 weeks, the open source community is taking all the things that we would want to do and doing it faster, making these models run on CPUs instead of GPUs, taking these models and teaching them new skills, adapting them in different ways. Let's not fight that, let's embrace it, give a good base and they can build on it. And so there was a question, briefly, back in the late December of like, oh my gosh, is this game over? Does ChatGPT win? They collected the data, now they've got the model. And the resounding sort of answer, I guess, from the community is no. And here come the models. So moving forward, there we go. Point number 2, the durable moat is data. So consider then when you're making these large language models, for the most part, these are standard model architectures trained on standard hardware for the most part. We've had to take some learnings around how to train at scale over the past few years. But that formula doesn't change much. There's not a lot of differentiation, even that people are trying to report around how exactly these models are being trained, so much as what they're being trained on. In the beginning, the BERT model, one of the first sort of large language models, was trained on Wikipedia and books corpus. And oh my gosh, that's so much text, and look at how much it learned. It was very exciting. And then the next sort of step of evolution was, can we find any more data sets to scrape? Let's pull from GitHub, Stack Exchange, PubMed, Archive, teach our models new skills. And sure enough, more data helped. They did learn more things. Bigger models to accommodate those moved right along. Before long, people realized, okay, I see where this is going. Let's just scrape the whole dang internet and create, the C4 corpus, the pile, and these have now become the standard kind of, big chunks of data that you can go and train any sort of open source model on. And it starts to result in a bunch of models that perform essentially very similarly to each other because we're sort of running out of public data to train them on. It was very exciting how much we could learn in terms of just emergent behaviors and things that a model learns naturally en route to language modeling. But this is a recent report, again, just this past month from DeepMind, showing that kind of from their experiments, and it's a great paper. I recommend you take a look if you're interested in this. But they're saying, that our model sizes have increased much more rapidly than the actual kind of data sets, and it's a little bit wasteful. They don't actually need to be this large. There's only so much capacity required for a certain amount of data. So really, data has become the new limiting factor. And given that we are already scraping essentially the vast majority of what's on the internet, the question becomes, where does the next innovation come from? And I think we can take as one good example of this what basically made the difference for the GPT models, where for a while it was this tried and true formula of bigger model, more data, bigger model, more data, bigger model, more data. And then things stalled for a couple years. We didn't see the same sort of release cadence between GPT-3 and ChatGPT. And what finally ended up making the difference was not just more unsupervised data that was public and available to everyone, but rather they ponied up for a manually labeled collection. So RLHF is a term you're hearing, reinforcement learning from human feedback. But the operative point there is human feedback. They collected new examples of labeled data, in this case, showing the model what it was still missing. It had a lot of knowledge baked in. It had learned a lot of things from scouring the internet, but it wasn't necessarily like giving the types of responses that delighted users. It hadn't learned that ability to follow instructions. So instead of kind of pointing to a bunch of data and hoping that it learns to do what you want, they decided, well, let's just show it what we want. Pay some millions of dollars to collect a large corpus of examples of a model following instructions well, and in a polite way and in a way that refuses to be toxic, and showing it what you want. And with that sort of additional data, they were able to get the model that then was top dog for a number of months here. So this is a formula that I would expect to see repeated. That's an interesting one back there because even as they collected task-specific data, it was really more show it how to follow instructions generally, but still a very general-purpose model. But more in the direction where I expect things to go is this is also just from this past month. Bloomberg released the first of what I consider these GPTU models. You could maybe look at some of the earlier things like PubMed GPT or BioBERT as precursors to this. But as far as an organization creating a custom model tuned to their data, their priorities, this was one that I found quite interesting. And if you take a look at what they did, they essentially said, let's take that same common crawl that everyone's using, that big dump of raw data, and let's mix in with it now a bunch of private data that we have that is both A, unique to us, but also B, more similar to the types of data we're going to care about in the future, the types of tasks we're going to care about in the future, and train the model on that as well. And they reported here, they were interested in seeing if they could preserve some of its general purpose abilities. That's that bottom table. But of the most interest is in that top table where they showed, hey, look, by training a model on our data and our tasks, we can get a model that is, they showed about 10% better on tasks in our domain, finance, and about 30% better on tasks for our company, the things that we specifically care about. So this is very cool from the standpoint of, hey, look, we can adapt this. We can make a specialized version that satisfies our needs in a much better way. But on the flip side, I'll also say, 60%, while that's amazing and fantastic for an out-of-the-box model used in a zero-shot way, that's also not the whole house. That's still a foundation. Wonderful that you can start from that for all of your tasks to then do kind of further refinement on. But for most enterprise automation tasks, you're not actually happy with 60% accuracy. And this speaks to this third piece of why I have high confidence this is the direction that we'll see the field go, which is the last mile is really where a lot of that value is actually created. How much more valuable to you is a model that's 30% accurate versus 50% accurate? That's 20% more accurate. That's still not deployable. That's still not actually something that you can use. It's not until you get into the higher regimes, especially for predictive tasks. Generative's a lot more forgiving. It's a human in the loop. It's a co-pilot. It's okay if it takes me a few attempts or I have to kind of guide you to get to where I want you to go before you give me that output of an email that I like or an image that I like. When you're looking at automation tasks, predictive tasks, you need a much higher bar, for quality before you can feel comfortable sticking this, in front of customers and making decisions and, potentially things that are attached to business value. So when it comes to actually getting that quality level that you're comfortable with, this is one way that I think about it and that I see resonating. There's a couple different axes to consider. One being basically How stringent are your quality requirements? Is this an environment where you need high quality for this to be useful? If so, expect that you're going to have to adapt. Adaptation required. On the vertical axis, how complex is my domain? Does my task look like the type of data that this model was trained on? Does it look like web content generally, or the types of things people talk about? Or is this fairly bespoke medical tasks or finance tasks, things that actually an expert would be required or an expert is used today in my company to label? And the more that your task or data looks bespoke, again, the more that you can expect to have to build off that foundation and do some adaptation. So the way to think about this then ultimately is if you're considering a stack diagram, what you want at the end of the day are applications. Generative, predictive, doesn't matter. Applications that can solve some problem. You're going to run this on some infrastructure, and you're going to build from some foundation model. And there are so many, and they keep coming, and they will keep coming. So if I'd say my advice to most folks developing AI today is, don't necessarily anchor to a foundation model because it'll be stale by 6 months from now. Design in your workflows, your patterns in a way where you can swap out for whatever the latest, greatest, or most relevant to your domain model is, but still expect that there's going to be a layer where you need to inject the things the things you care about, the nuances of your data, the distribution that is actually reflective of a production environment, rather than the sort of generic pre-training where these base models are created. And this is something that, this is just speaking from some use cases that we've worked on at Snorkel with different customers, where we now say basically for every task, don't start from scratch, start from a foundation model, see what it'll give you. For very simple tasks, if prediction quality is high enough, great, ship that or distill that model into a smaller model that you're happier paying inference cost for and ship that. But most of the time, we see results like this. Again, awesome that I can do this out of the box. Amazing that with no specific training, this can get 40, 50, 60%. But that's not a whole house, and that's not a satisfactory application you can go and deploy. So instead, we see this fine-tuned, this step where you go and are adapting, where you're adding in kind of task-specific information to actually get this kind of over the hump and ready to deploy. And this applies across verticals, across task types. This is image, this is text, this is chat, this is information extraction. Just a very consistent story. And it makes sense even just from like an information theory standpoint. How can one model serve all the different use cases when two businesses with the same vertical and use case may even just have different preferences for what's acceptable or where's the line between class A and class B? There needs to be a place for you to inject your knowledge, and that comes in this final adaptation step. And this is not just kind of what we're seeing on a smaller number of individual examples, but there's a handful of good surveys that have come out, again, like everything else over the past month, because this is a wild time to be in AI. But good results showing large-scale comparisons. This was one of them, looking at, hey, let's apply ChatGPT to a bunch of benchmark tasks and see how does it compare to current state of the art, a model that's been fine-tuned or specialized for this task. And consistently, in this case, 25 out of 25 tasks, they found that, kind of no surprise, the specialized model outperforms, typically by a decent margin, by 25% on average. And the harder the task, the larger the gap between these, which, again, not surprising, and speaks to that quad chart we saw before, where higher production quality requirements or more bespokeness of your task means more adaptation can be expected and more lift over one of these kind of generic models. So this is the only plug I'll make for Snorkel specifically, but this just speaks to kind of why this is where we focused as a company, as a product, is this idea that foundation models going to keep on trucking. The big companies are going to toss their hats in the ring. The open source community is going to be right there next to them. We sort of don't care what foundation model you're building from. The idea is to be orthogonal to that, agnostic to that, but recognize that there's going to be this adaptation that needs to happen, and making that as efficient and guided and natural as possible for you to rapidly map any one of these foundational models to a specific use case that you have, and that's a valuable thing to do. And that there are ways to speed this up. This is where we pull on some of our history with programmatic labeling as just a dramatically more efficient version of labeling compared to manual labeling. I won't go into the details here. You can find that on our website. But this is the paradigm I expect to see quite a bit more. For individual applications, expect an adaptation step to be required. And after you've done that adaptation, you can modify the original model. You can distill it into a smaller model. The important piece being you've taken the relevant information, added the piece that makes you, and then you're now ready to go ahead and deploy this. So last, the bonus section, I'll call it, is what does this mean sort of, next? Let's not look one step forward, but two steps forward. In a world where people are making kind of organization-specific models and tackling these tasks this way, what does that open up for you? So to rehash one point, these generic models trained on anything and everything can do a lot of things across a wide variety of tasks. Some, generative, write me a poem. Some predictive, answer this question. But in the way that we sort of saw from that paper and from our own experimental results, these models do end up being jacks of all trades, but masters of only the simple. Again, that's an interesting color choice that it made automatically. But the point being here, consider here that we've got 3 tasks now that are not the broad breadth of, hey, can you do any weird task that I ask you, but more like, I'm a company, I'm a business, I've got a specific area I care about. In this case, let's say it's furniture. Can it answer, is there a couch on this picture? Almost certainly. That's a pretty easy task that looks a lot like web data. But suppose, I'm a retailer who needs to, organize my stuff by particular styles and properties. Is it going to know what a Chesterfield couch with what nailhead trim is? Probably not, and if it does that, there's going to be other areas where it misses. And so, we need to find a way to improve its quality on these different tasks that are not, the sort of simplest versions that are solvable out of the box. The way you do that, as I described on the previous page, is with this task-specific adaptation. Build on that generic foundation model, find the information that they're missing to do this specific task well, and inject that via a task-specific data set and process for doing this update. Now, what's interesting is you can push some of this down one level further into the foundation model. This is where I'd say we move from take a fixed foundation model and then tune it to specific tasks and say, if I'm an organization that has a number of tasks, has a decent amount of data, there are ways that you can go and actually refine the foundation model itself, convert that GPTX into a GPTU, which you'll still build applications on, but some of what was previously too hard for it to solve out of the box maybe does become more obtainable because it has that much more relevant representations and nuance in your field. And then where you do still have hard tasks, that much higher of a starting point means less work to get to production quality and potentially higher results at the end of the day. So at the end of the day, it all comes back to data, and where data is being injected. And the idea is just that you can, at different levels, sort of inject increasingly relevant data to get the highest performance on specific tasks. And the flywheel aspect of this then looks like this, where anytime that you are doing this task-specific adaptation, where you are adding additional labeled data to perform some specific task better, it's not like a one-time throwaway cost or something that only applies there. You are providing additional signal that can and should be used to further improve your model as well. If you don't own that model, if that model is GPTX, there's not a lot of incentive, I guess, for you to share that data and make their model and everybody else's usage of it better. But if you own the model, especially if you're using one of these open source models that has a solid foundation, a lot of great work from a lot of great people giving you that starting point, then with any additional work that you do on top of that, you now have additional relevant data that you can cycle back to improve it. And this is something I expect to see. It builds on well-established kind of research and work in this field, multitask learning, which once upon a time there was kind of a question of what's going to be the big next step in machine learning. Is it going to be more self-supervision or multitask learning? And people place their bets in different places. As usual, I think the answer is going to be a bit of both. But this is something I'll expect to see, which could result in some more of the differentiation happening over time, where an organization does have a chance to not just be doing the same thing that everyone else is doing, using the same model that everyone else is using, trained on the same data that everyone else's model was trained on, by taking the best advantage of the data that you have in-house. So to sum up, number one, I do believe AI applications very soon will for the most part be built on foundation models. There's just no reason not to when they give you so much out of the box to build on. There we go. Where's the differentiation going to come from? Ultimately, it's going to be from training on your data and your workflow. In addition to things like, as the panel mentioned before, experience, the customer experience and how exactly this is productized. Don't want to undercount that. That's huge as well. But from a pure kind of model accuracy standpoint, the data is going to be what moves the needle. Third, production quality ultimately comes from that last mile adaptation. So I would say, don't necessarily, sell all of your AI tooling in-house and assume that it's all going to come to you for free from these open models. That that need for kind of last mile data curation, specific task data collection, just as evergreen as ever when it comes to getting production level quality. And then finally, and this one I'll admit it was maybe 2 steps forward, but where I expect things to go at the end of the day, if you have this shared foundation, there is a chance for you to create a model that's not becoming less relevant over time, but actually becoming increasingly relevant over time as more and more of your differentiated tasks and differentiated data is used to make it increasingly aligned with where you are moving forward and increasingly separate from the kind of open pieces that everyone's playing with. And with that, I'm happy to take some questions.
The question that I had, and I'm sure you've thought about this, although you didn't present it, and maybe it is something that would come in one of the adaptations, or you'd maybe integrate it in one of the models, but what are we going to be doing about AI security? I work for a big bank. So if we hear obviously about financial security, but every business worries about, fraudulent attempts at their intellectual property. Are we really hearing from the person that they are saying we're hearing from, so that we can provide confirmation? So where does that get integrated and who's working on that?
Yeah, that's a great question. And
Great question.
There are so many facets to security that I can't possibly answer to all of them, but I'd say a big piece of that is the question of just in general, people are realizing, we need to hold tight to our data. And that's a big blocker that we partner with a bunch of these FM providers making their models available on our platform. And that's a blocker we're hearing from them is, people love the idea of our model. They're happy to play around with it. Nobody actually wants to send us their data. And so that's part of the reason why we're seeing a lot of interest in, great, can we have that but in-house? Can we have that but owned by us, controlled by us, fully inspectable by us? Both partly just to manage kind of where data goes and what, others not being able to kind of back out from your model specifics about your data. But then on top of that, having the chance to, in some cases, distill information into model architectures that are more interpretable. There sometimes is a loss when you move from, it's a trade-off space. These deep models can perform very well, are not very interpretable. And we do see model risk management teams feeling kind of concerned about this. How can I tell what my model's been trained on or what it's going to do? And that is an option, is to say, here's a model that we have a long history with, that we know how to inspect and interpret, that we can compare to past versions. Can we transfer the knowledge from these great models into the one that we know and trust and control? And that's the way you do that's via training data. You'll take the predictions of that model on your data, use that to train your model, and you can transfer the vast majority of the information, but then in a wholly controlled, wholly private environment. That's just one facet of privacy, certainly, but that's one that we're hearing about.
Thank you, Braden. Thanks a lot. It was a pleasure and an honor to have you here. And this was a last-minute change. We greatly appreciate your flexibility. Friends, as the track comes to an end, I want to again thank the track chairs, Ashish Bansal, Surbhi Kaul, Lalit Gazare, our amazing track manager, Nikhil. Let me quickly summarize the track today. It was an amazing set of panels and keynotes, with Debanjan starting by telling us what are the real-life use cases for generative AI. Ashish Bansal's track talking about B2B and B2C challenges of generative AI. Dr. Pandyan's track talking about how to marry MLOps and generative AI. And then the most fascinating panel, Surbhi's panel on marrying artificial intelligence with customer success. Thanks, everybody. And then Braden basically helping us understand how this field is going to emerge, where foundational models will be fine-tuned for real-life applications. Thank you. Thanks a lot, everybody. Without the presence of the audience, this would not have been a success. Thank you. Thank you.